Hi, I'm Tom, amateur reader call sign N8FDY. And today we're having another multimeter review. This time it's a Fluke 177. We also have another guest star, which is a Fluke 179 that is 20 years old. So we're going to compare brand new 177 to the 20-year-old 179. The only thing the 179 does more than the 177 is the 179 can measure temperature, and it comes with a thermocouple. I have no way of accurately testing temperature, so we're not even going to worry about that. So let's get started. Let's see what's in the box with the 177. It's a big box, which I did upside down. Okay, you get the meter. You get a whole bunch of safety something gobbledygook, and then you get a little reference card. And I mean little, not much on it. If you want to read the manual, you're going to have to download it from the Fluke website, because they don't supply manuals anymore. That's one of the differences between the old meter and the new one. This old meter came with a manual, a full manual. All right. Oh, and I forgot to mention that of course, you get the Fluke stiff plastic test leads with the little, I guess these are the category 4 protection covers that go on them. Oops. Which I think everybody takes off. At least people use it as a bench meter. Let's run down the features of these meters. They are CSA listed in USA and Canada. It's Cat 3 1000 volts, Cat 4 600 volts, 6000 count meter. Its basic DC accuracy is 0.09%, plus or minus 2. Its true RMS has a 33 segment analog bar graph. It has a min-max average function. It has a hold, and it also has an auto hold. The 179 has a K-type thermocouple. The 177 does not measure temperature. It has auto-off override, backlight off override. You can disable the beeper. It has a smoothing mode, and it came with a 9-volt battery. It has the Fluke limited lifetime warranty. Here's the Fluke 177. The other difference is and it's not because of the model number, it's because of the age. 20 years ago, they did not have the feature where you could override the backlight auto shutoff. Nothing happens with this, but with this, you hold down the backlight button, turn it on, and it goes into auto shutoff override for the backlight. They also have the same feature for power off. So if you hold this down and turn it on, it will override the auto power off. This doesn't have any of that, but it's 20 years older. So Fluke silently improved the meter without really much fanfare, I think. The other thing they changed is the voltage for testing diodes. The 177 has a higher voltage than this 20-year-old meter. Anyway, the other thing you'll notice between the two is that Fluke has, over the years, improved the backlight. It's much brighter on the modern version than on the old 20-year-old version. I definitely prefer the modern version. Now we're going to measure some DC voltage. On the left here we have the 177, and this on the right is the 20-year-old 179. So 2.5 volts, they're pretty close. Here is 5.0009. Shows up as 5.001, which is acceptable roundup, so that's very close. And then 4.998. So a little tiny bit low, but definitely within spec. And here's 7.50, 7.50 on both. You notice that we lost 1 digit of precision because we went past 6,000. So as soon as you get higher than 6,000, since it's a 6,000 count meter, it slides over and you lose a digit of precision. And there we go, 10. So they're both pretty close. I'd say for 20-year-old meter, it's still doing pretty good. The DC voltage measurements for both meters met the accuracy specifications in the manual. Also, the millivolt accuracy specifications is the highest or most stringent of all the 6,000 count meters I tested. Now we're going to do AC voltage. I'm using my arbitrary waveform generator to generate a 60 hertz sine wave at 2 volts. Well, as close as 2 volts as I can adjust it. That's why we have the Fluke 289 here, to see how close it is to 2 volts and then compare how the other 2 meters do. So, we have 2.0013 and the 177 says it's 2.005 and the 176 says it's 1.998. So that's not too bad. All the voltage readings on the 177 met the accuracy specifications in the manual. The 179, the 1 millivolt was off. It was off by a lot. But all the other voltages met the specification. So I guess for a 20-year-old meter, you can't blame it for being a little bad, but the new one is just fine. The Model 170s don't have a microamp range, and I think you need a microamp range for electronic hobbyists. Now with battery-operated things that run less and less current, you definitely need a microamp range so you can figure out what your battery life's going to be on your project, or you can figure out if something's drawn too much or too little. And a lot of microcontroller projects, again, when they go into sleep mode and other modes, they could be down in the microamps. So we're going to measure some milliamps and above, but we will show you what it does when you put some microamps in there. The meter can resolve down to 0.01 milliamps, which is 10 microamps. So let's put 10 microamps in and see what it does. 9.21 microamps. And the meters don't, well, the old meter, 20-year-old meter, doesn't see it at all. And the modern version of that meter sees 0.01. Let's try 99 microamps. Well, they both see 0.1 milliamp, which is about 100 microamps. So that's pretty close. Here's 131.8 microamps, which would be about 0.14. And they're a little different. The old one reads 1.3 and the new one is 1.4, or fluctuates back and forth. So that's not bad. Now we'll go to 1 milliamp, which they both should be able to measure no problem. And it says 1.01 milliamp, and the other one says 1.00 milliamp. So they're, again, pretty close. Here's 9.96 milliamps, and the one says it is 10.03, and the other one says it's 9.98. Here's 99.4 milliamps, and we're getting 99.4 on the old one and 99.8 on the new one. It is interesting that the old one is a little closer than the new one. All the current readings were within the specifications stated in the manual. The meter couldn't read the 0.896 microamps. And as you can see that the uncertainty values are really low for the microamps because we're actually using the very low end of the milliamp scale. So this meter really wouldn't be that helpful and accurate in microamps. The accuracy specifications for the milliamps and the amps are, kind of middling. No, wasn't the worst, wasn't the best. Here we're comparing the accuracy specifications for volts and amps on those 6,000 count meters that I tested. The red background on the meter model number indicates that they are not third-party safety tested. All the other ones are. And the 177, 179 standout is the millivolt DC range. Most accurate meter in that range. It's kind of mediocre in between the other accuracies, but it doesn't do DC microamps or AC microamps. So that's one of the reasons why you probably don't want this meter for your electronics projects. The meter uses a 9-volt battery. You have to remove 2 self-tapping screws to open up the battery compartment. And you have to be really careful putting those screws back because you don't want to wreck the plastic. To change the fuses, you have to remove the battery door and those 2 screws, and you have 2 other screws you need to remove. They're all self-tapping screws into plastic. Here's a close-up of where the 440 milliamp and the 11 amp fuses go. Well, so much for the parallel readings. Now we're going to go to resistance, which we really can't do that in parallel. First we'll zero the leads and see what we get. We get 0.2. Unfortunately, this meter does not have a delta or relative function. We're going to have to manually subtract 0.2 from the low ohms readings. Let's see what this guy says. He agrees, 0.2. Here is a 1.004 resistor that was measured on the Keithley MM6500, which was calibrated about February. And here it says it's 1.2, which we have to subtract 0.2 from that, so it comes out to 1.0. Let's see what this guy says, the old guy. The old guy says it's 1.4, 1.3. So I'd say the new guy's a little closer on this. Here's a 10.007. And, well, we're getting about 11 ohms, 12 ohms. Let's make sure these are tight. And this is good. Still, 10.5 ohms. Let's see what this guy gets. 10.3, a little closer. Who knew the old guy'd be better? Here's 100.069, and we get 100.2. If we subtract out the 0.2 from the leads, we get 100. That's pretty good. we get 100.9, 100.1. So if they subtract out the leads, it'd be, oh, now we got 100.2, same as the other guy. I guess the old guy takes a little while to figure it out. Here is 1.0001 kilo ohm. And we get 1.000 kilo ohm. Here we get 1.001 kilo ohm. So now the new guy's a little closer. Here we got 10.002 kilo ohms, and this shows as 10 kilo ohms. And this shows as 10 kilo ohms also. This is 9.97 mega ohms. We get 9.95. And 9.97. Old guy's closer again. So far, so good. If you want to know the other resistance values, it's in the written review, which is mentioned, the link to that is mentioned in the description of this video. So be sure to follow that link to my GitHub site that has the written review for these meters. So all my video reviews come with a written review at my GitHub site. All the resistance measurements met the accuracy specifications in the manual. The accuracy specifications are about average, middle of the road for this class of 6,000 count meters. Now we're going to do some capacitance. These only resolve down to 1 nanofarad. So I'm not going to even measure my 10 and 100 picofarad capacitor because it would be kind of pointless since they can't resolve near that. That's another reason why you might not want to use these meters for electronic projects. Here's a 1.005 nanofarad capacitor, and we see that the new guy reads it as 1, which seems pretty obvious. And the old guy reads it as 2, so he fell down on that one because that's 100% off. So I know that doesn't meet the specs. So the poor old guy's not good on capacitance, at least not with the first 1 nanofarad. Here's 9.921 nanofarads. And the new guy has it at 10, which is acceptable rounding up. And the old guy got it at 10 too. Here is 99.51. The new guy rounds it up to 100. And the old guy rounds it up to 100. Here's 1.09 microfarads. The new guy, he stayed in nanofarads, so he has it as 1,008 nanofarads, which is equivalent to 1.008 microfarads. The new guy, the old guy puts it in microfarads, and he reads it as 1.01 microfarad. Here's a 10.294 microfarad. The new guy reads it as 11 microfarads. The old guy reads it as 11.1, 11.2. Well, I can't make up his mind. Here is 10.294 microfarads, and the new guy reads it as 11. The old guy reads it as, man, he can't make up his mind between 11.1 and 11.2. Here's 112.2 microfarads. And we get 112 on the new guy. And 114 on the old guy. Here is 944.5 microfarads, and the new guy reads it as 1,001 microfarads. The old guy reads it as 1,011 microfarads. 1,010. Oh, can't make up his mind. Oh, yep, he's still deciding. So we'll just call it 1,010. Well, the capacitance that could be read in my initial testing all met the specifications as in the manual. The specifications for the higher end microfarads are the worst specification in this group of 6,000 count meters. Also, the 1 nanofarad, the uncertainty value is so large that that reading is not very useful. So you're going to have to do the 10 nanofarads and above are probably okay. As you can see here, by comparing the accuracy specifications of the 6,000 count meters, the resistance and capacitance is about middle of the road for the 177 and 179, except for the high microfarads, where it's the worst accuracy of the group. Now we're going to do some diode testing, and we'll start out with the LEDs. The red LED is bright, and we get a forward voltage. On the old guy, the LED is dim, and we get a forward voltage. So one of the things that changed over time is what voltage they use for diode testing. It definitely got higher on the newer version. Now we have the yellow LED, and it's pretty bright, and it has a forward voltage reading. Let's see what the old guy does. Oh, very dim, but it does have a forward voltage reading. Now we have the green LED. It's pretty bright. Not as bright as the other ones, but still good, and it has a forward voltage reading. Green LED is very dim on the old guy, but he does have a forward voltage reading. Here is the Schottky diode. Let's see what the old guy does with the Schottky diode. Here's the small signal diode. And the small signal diode on the old guy. Here's the rectifier diode. And here's the rectifier diode on the old guy. How did I forget continuity? Well, it's a day later, and I'm going to do the continuity now and slip it into the video. Let's get to it. First, we got to turn on the meter, override the auto backlight off, and let's put it over into continuity. There we go. Now we're going to use the probe masters, so that way nobody can blame the leads for giving this guy a bad performance. And we'll see what happens. Well, looks like it's latched. This is the loudest beeper of, I think, all the 6,000 count meters I've used. Seems pretty fast. It's fast enough for me. Anyway, that is your continuity for the 177. We're not going to bother with the 179 because I don't think any of you are going to buy a 20-year-old 179. At least I wouldn't recommend you do that. The improvements they've made in the past 20 years under the 170 line, you definitely want to get a new one. Well, let's look at the pros and cons of these meters. Well, the good parts of this meter: it's third-party safety tested by CSA. The DC millivolts accuracy specification is the best in this group of 6,000 count meters. The DC voltage accuracy specification is above average in this group of meters, and it has the Fluke limited lifetime warranty. Well, now the bad parts of these meters. There's no microamp ranges. There's no relative or delta function. Capacitive values under 10 nanofarads really aren't useful. The high microfarad range is below average accuracy. The battery door is secured with self-tapping screws into plastic, and you have to disassemble the meter to change the fuses. I have to admit, this has been an old standby for me, this 20-year-old meter. I did recognize its weakness when I wanted to do microamps, and it can't. And for doing low ohms ranges, I wish it had the relative function. I don't really like that it doesn't have that. I do like the backlight. It's nice and bright. On the new version, the old version, well, maybe I should. All right. First, let me tell you the differences I discovered between the old and the new version. The old version had a dim backlight, and it would go off, and you couldn't stop that. The old version used a lower voltage for diode testing and resistance testing. And the old version didn't have a backlight timeout override, and it didn't have a power off override. So I didn't know any better at the time, so it was fine. But I think it's held up pretty good over 20 years. I believe that the improvements they made is well worth it. I think that at $275, this meter was pretty good buy. This has the best accuracy for millivolts that I've seen in this group of meters. And it's pretty good on the other parts too. Again, I think there's better choices. And if you need temperature, you have to move up to the 179. And unfortunately, there's a gigantic price increase just for that. I haven't found a 179 any cheaper than $400 anywhere. And I definitely would not recommend buying a 179 for $400 because you can get a 87 Roman numeral 5, which a lot of people call the 87V. You can get that at Lowe's online for $319. And that it is a bigger meter, bulkier, but it has a lot more functions, and it has tighter accuracy in many areas. So I would definitely say that if you could live without microamps and you want a smaller meter, if you can find the 177 and you don't need temperature, you find a 177 for under $300, it might be a good choice for you. But I think for most people, for electronic projects, the 87.5 or the Brymans, the one that is badged as Greenlee that we reviewed, the 510, that's a good one. And of course the EEV blog Bryman is a good one. And those are both in the $150 range. But if you want the highest accuracy of all of the 6,000 count meters, it's the 87 Roman numeral 5 Max is the one that has pretty much the best accuracy in most areas. There are some where other meters are better, which is really weird. We'll go over that. I think that wraps it up for the 177, 179 duo. I hope this helps. And again, I would say this is probably good for an electrician and a maybe appliance guy. But for electronics, we definitely want to have that microamp range. So, This is Tom, N8FDY, saying 73, and take it easy.